In this unit, we're going to discuss, or in this presentation rather, we're going to discuss access control very broadly. So I'm going to talk about, very broadly, talk about authentication, or how we identify a user, and then authorization, or different methodologies for giving access to information, and a little bit about the difference between those two. And we're going to talk about some specific technologies that support those concepts. So we'll talk about a few specific security technologies. As you might guess from the unit label, this unit and the next unit are mostly about security technology. So all these different technologies that support many of the concepts that we've discussed previously in this course. So let's talk about access control and authentication. So the first thing we discuss usually in a course like this is authentication. In other words, how we identify a user. So authentication is all about identification. We want to make sure who the user is. We know who the user is before we decide what they can and cannot access. So it's important to identify them. So for example, if you had a laptop, a user might log in with a username and password to the laptop computer. They're authenticating to that laptop computer. And that laptop computer might connect to the network. So we might have authentication that authenticates the laptop to the network, or the user that's logged into the laptop to the network. And we'll talk about different ways to do that. But authenticating only approved users and controlling their access to resources are important foundations of information security. In other words, having authentication, knowing who people are, and knowing what they can access is the foundation of IT security. There's a lot of services and a lot of work that we do to make sure that that works properly. So a lot of times we talk about authentication factors, and I'm sure a lot of you guys have heard this. Generally, we talk about the three factors of authentication. There's something the supplicant knows. By the way, the vernacular supplicant refers to the person who is trying to log in. So usually something that someone knows could either be a username and password or a PIN number and so forth. I think the vast majority of systems rely on username and password for authentication. That's by and large the most common way that we authenticate to systems. And then the second option is something that a supplicant has. So this could be a dumb card, like an ATM card or an ID card with a magnetic strip or an RFID on it. I'm sure a lot of you guys have jobs where you have to either swipe a card or scan a card to go through certain doors, or you may even have them to access computers. It's getting more common now that we use our ID cards to log into computers and networks. A smart card, which contains a computer chip, and I'm sure all of you have noticed that now our credit cards have a smart chip in it. So now you insert your card into the key pen, and it sure seems like it takes a lot longer to charge your card than it used to with that. But that would be an example of, again, something that you have, and they've been around for a long time in computing security. The credit card companies have recently adopted those. Synchronous tokens and asynchronous tokens, these are things that are, you may have seen those little keychains like the RSA keychains that have a number that changes periodically, and you have to have that number in order to log in. And because the number is constantly changing, you can't just, take a picture of the number and go and log in 2 hours later. That number would have changed, 100 times by then. The other example of that we see now a lot is apps on cell phones. So now a lot of companies, you install an app on your cell phone and it gives you an access token that you use to log into the network. So you not only have to put in your username and password, but you have to put the access token in. And a lot of you may do this for your online services like Gmail or Yahoo and so forth and so on. A lot of these online services now support two-factor authentication. So two-factor means it has two of these components. So in this case, something that you know, which might be your username and password, and something that you have, which might be your cell phone, which has the app on it, which gives you the authentication token. And sometimes they have them where it just sends you a text message of an authentication token. So you get the token via text. Somebody would have to tap into your cell phone and get your text messages in order to get that, which would be highly unlikely. And then the third factor is something that you are. So something you know, something you have, and finally something that you are. So that would be things like relying upon characteristics about you. It's considered very strong because it's very hard to fake a lot of these things. And usually when we talk about something that you are, we're typically talking about biometrics. So biometrics is using some measurable human characteristic or trait to authenticate your identity. And this could be fingerprints, it could be a retina scan, scan of the eye, and so forth and so on. It could be, and it could be things like looking at how you type, We've started seeing a lot of systems now that authenticate based on how you type your password, because there's certain patterns in how people type that you can kind of fingerprint somebody from that. We have voice authentication. There's lots of different ways. So there's a lot of things about you that can be measured, that can be used for authentication, like fingerprints, palm prints, handprint, and geometry scanners, which a lot of time clocks use now, signature recognition or handwriting recognition, facial recognition, voice recognition, retina rather. So um, there's a lot of things that we can use that are inherent about you that would be difficult to copy. And we discussed this just briefly in the unit about physical security. So we did talk about some of that stuff. Once you have the ability to allow people to log in, our next step is to have some accountability or some logging. So accountability is ensuring that all actions, whether authorized or unauthorized, can be attributed to an authenticated entity. So in other words, once we know who you are, we want to lock in that user ID or that person to all of the actions that they're taking on the network. So we have some record of everything that you're doing. It's sort of like that logbook that we talked about in physical security, where you sign in and sign out of the building so we know who was there. So most often accomplished by means of system logs and database journals and auditing of those records. One of the challenges that we have with accountability is these logs are splattered all over the network on all different services. So you have one set of logs in your database service. You might have other ones in your firewalls, your routers, and your Windows server that does authentication for Active Directory, for example. They're all over. So there are applications that can aggregate those logs for auditing purposes. And auditing is, of course, is very important. There's a whole subset of IT just dedicated to auditing. You can take whole certification exams about auditing, and there's whole academic programs dedicated to IT auditing. So certainly an important area of IT, but our job in IT security is to make sure that that auditing is possible, that we're capturing enough information in a useful way that could be used by for somebody to do auditing. So again, that's pretty important. So access control, authentication. Access control is granting or denying approval to use specific resources that is controlling access. So once someone is authenticated, access control is making the decision as to whether or not they should be able to access a certain resource. There's physical access control, which we talked about in physical, but here in this unit we talk about technical access control, which are technology restrictions that limit users on computers from accessing data. So where the physical access control was to the physical plant or to the physical location and so forth, through certain doors and so forth and so on. Now we're talking about access control within software or to access specific data. So access control has associated set of terminology to describe actions, and we're going to talk about those. So some of the terminology, you have identification, which is presenting your credentials. And by the way, identification doesn't necessarily mean, when we talk about technology, identification isn't always, username and password. That sometimes has already happened, and we have some kind of authentication token that some of these technologies sort of attach to a user that can be presented as they try to access different resources on the network. And we'll talk about that with things like Kerberos. So authentication is when we actually check their credentials. For example, examining the driver's badge or something like that. Authorization would be granting permission to take some kind of an action. So an object is any resource to which we're controlling access, and the subject is the user that is trying to access that object, and the operation is the action that is taken, such as trying to read a file, write a file, delete a file, and so forth and so on. All right, so there are the different actions. We have identification, authentication, authorization, and access. And the technology, we have owners, custodians, and end users. Let's talk about that in a little bit more detail. So in the vernacular of IT security, a subject is the end user that's trying to access some resource. The object is the resource they're trying to access. In this case, salary.xlsx would be a resource, obviously one that's probably pretty sensitive. There's an owner, so the owner is who owns the file, right? So in this case, maybe that's the department managers, for example, might be the owner. And then the custodian is the party that is responsible for that data, or responsible for the protection of that data, and so forth. So The custodian, in our case, mostly the custodians are IT security people. So maybe the people that administer Active Directory, for example, might be considered the custodians. And then end user is anyone on the network, whether they can access the file or not. They're an end user, because one of the things we do is decide whether or not they can access it. And then the owner is the data owner. So not necessarily the owner of the file, but who owns the information in that file. Who is the direct controller of that file, or who makes the decisions about that file. And of course, that's all supported by the custodian of that file. And the operation is when we try to log in, try to access it, try to read, try to write, try to delete, and so forth and so on. Those are the different operations on that file to which we're making a decision as to whether or not the user can carry out those operations. So some access control models. So an access control model is some kind of framework that a custodian can use for controlling access. And there's all these different models that are kind of already defined for us. There's 4 basic categories of access control models. You have discretionary access control, mandatory access control, role-based and rule-based access control. Both are RBAC or RBAC. Probably the most common of these 4 is discretionary access control, because it's the simplest and the easiest. So normally you have access control methodology. They're in 2 categories, either discretionary or non-discretionary. The important thing about discretionary is that it's controlled by the user, where non-discretionary is controlled by the custodian. So a little bit different. And then within the non-discretionary, you've got these different models that we're going to talk about. There's actually a whole bunch of different models that you can use for non-discretionary. Discretionary, there's really no models for, because it's a pretty simple concept, but I'll explain it here. So discretionary access control is the least restrictive model. So every object has an owner who has total control of that object. So that means any object always has an owner, and that owner has complete control. They can do whatever they want with that object. They can grant control to anyone. They can restrict access to anyone they want. So they have the control. And not only that, as a custodian, we have the ability to configure, when a user creates a file, what the default restrictions are on that file. So what their default permissions are. So on some networks, administrators make it so when you create a file, you're the only one that has access to it. And in other networks, you might make it so everyone who's in your group has access to it by default. If you want to restrict access, they can further restrict it. Or if it's a restricted type network, a user could make it so that more people can access that file somehow, through whatever method they use on that particular technology. So if you think about it, things like Windows, I think all of us are familiar with using Microsoft Windows. That is a discretionary access control model for the most part in the NTFS file system. You create a file, you have ownership of it, and you decide who gets what access to that file. It's pretty straightforward. So again, Microsoft Windows probably is a good example of this. So the owners can create and access their objects freely. An owner can give permission to other users over those objects. And of course, it's used, as I said, in Microsoft Windows and Unix and Linux and so forth. By default, use that, although you can modify Unix and Linux to be a little bit more secure and use some of the other models that we're going to talk about. So there's the window that you probably are familiar with in Microsoft Windows, where you can change permissions on a file, and you can grant access to read, write, modify. You can give full control to another user and so forth and so on. Or you can take control away from other users, as long as you're an owner of that file. So some of the weaknesses, it relies on a decision by an end user, and we've talked about that before, how end users are something we don't have a lot of control over. We can do all the education in the world, but people make dumb decisions, and we're kind of relying on those people to make good decisions with their data. And I'm sure there's not many, there's no shortage of stories about people who work for a company that accidentally give access to files that they shouldn't have. This recently happened at the company that I work for, where it was identified that somebody created a file that was very sensitive, that had HR data in it, and they did not use the correct permissions, and everyone had access to the file. Of course, management found out and said, "How did this happen?" And it just turned out that a user just didn't know or forgot or didn't think about it, and just never changed the permissions on the file. So of course that had to get remedied. So subject permissions will be inherited by any programs that the subject executes. So and this is a common method of attack, where when we carry out an attack, we want our malware or our code that's being executed to have the highest level of permissions possible. So if I can simply get my program to run in someone else's user space that has permissions to do what I want to do, then I have more permissions for the program to do things. So anything that that the user executes is going to have their level of permissions to all of their files and so forth and so on. And again, that's another weakness of discretionary access control. I should probably tell you, why do people use discretionary if I just talked about all these weaknesses? It's the simplest to configure. It's the easiest to configure. It's the least number of headaches on the day-to-day basis, right? So you're as an IT security manager, if you use discretionary access control, users aren't calling you saying, I can't access my files, or I can't access this file or that file. They can simply work together to access their files. If John Doe wants to access a file from Jane Doe, he simply picks up the phone and calls Jane and says, can you give me access to, the whatchamacallit files? And everybody's happy. So, but with mandatory access control, it's a little bit different. In mandatory access control, it's sort of the opposite of discretionary, where rather than the users having direct control over their files, the custodian has control over the files. The custodian is the one that makes the decision or sets the settings as to what they can and cannot do with files. So even if a user creates a file in mandatory access control, that doesn't necessarily mean that they have control of the file. They may be able to create the file and not edit it. They may be able to create it and not give it to someone else or something like that. So the two key elements are labels. Every entity is an object, whether it's a laptop, a file, and so on and so forth, and assigned a classification label like confidential, secret, and top secret. You've probably heard of those terms before, usually in reference to when they say something is classified, they mean it's classified into one of those as either confidential, secret, or top secret, for example. If something's not classified, that means it's just public. So the subjects are assigned a privileged label based on what they're allowed to access. So if I'm a subject, then I can. So you have objects and subjects. So if an object is labeled as secret, then the subject has to also be labeled as secret in order to access that object. So levels are hierarchy based on labels. Could also be used both for objects and subjects. For example, top secret is a higher level than secret. So for example, if a file is labeled as secret and I have top secret as my classification, then that means I can still access all of those secret and confidential files that are below my level. One thing that I think your book doesn't talk about very well is this concept of read up and read down. When we talk about these different classifications, in some of these mandatory access control models, you have no read up and you have write down with no read up, or write up with no read down, which means that if you're at a secret level, you might be able to read documents above your level but not write to them, and you can write documents below your level but not read from them. And likewise, it could be the opposite, where you can read up, but you can't write down below your level. So there's different reasons that you would do those different models, but that is a concept I think it's important to be aware of. But your book doesn't talk about it too much. So these are some of the mandatory access control models that your book talks about. The lattice model, Bell-LaPadula, which is probably one of the most common that people talk about, which is very similar to lattice. But subject cannot create new objects or perform specific functions on lower level objects. So that's our read up but no write down, for example. There's BIBA integrity model, the mandatory integrity control model, or MIC, which is a derivative of BIBA. So these are just 4 models. Again, you can read about them in your textbook, but these are 4 mandatory access control models. And of course, different technologies implement these models a little bit differently, but you can implement technologies that support these various models. So for example, Microsoft Windows uses a sort of a variation on Bell-LaPadula model for user access control, which is if you try to run a program that's configured or classified in a certain way, you have to explicitly give permission, or your administrator has to come over and give the operating system permission to run that program or to touch those files. So it doesn't allow you to do it. And of course, this is one of those management things that drives us nuts in IT when our organization forces the use of these types of mandatory access control, And every time somebody needs to access those files, somebody has to come along who has permission and put in the username and password. And there's been some debate in IT security about whether or not this is even a good thing, because sometimes people get worn out from having to go around and provide permission to do all these things, and they end up just giving users the password to do it themselves over time. So that certainly happened. So you do have to be diligent to use these models. So they're generally in areas where IT security is a much bigger concern in certain organizations in certain areas. Certainly, national security would be a good example. I think we're all familiar with the idea of classification for national security, because we hear about classified documents, and you hear about that in the news and so forth and so on. So role-based access is kind of more of a real-world access control than the other models that we've talked about. It's based on a user's job function within the organization. So instead of setting permissions for each user or group, you assign permissions to particular roles within the organization and assign users to those roles. So objects are set to a certain type to which a subject with that particular role has access. And the other example is rule-based access, which dynamically assigns roles to subjects based on a set of rules defined by the custodian. So each resource object contains a set of access properties based on those rules. So, and those would be things like access control lists. So if you're familiar with Microsoft's Active Directory, that's a great example of both role and rule-based access control. It combines both. So both are used in something like Active Directory, where you have rules, which are access control lists or ACLs that you can use for controlling access with things like group policy, but you can also apply group policy to roles within the organization. So for example, certain roles can do certain things, and you can set up rules that specify access and permissions to certain resources based on some kind of rule set. There are, not mentioned in your book, there are other access control architecture models. Clark Wilson is one, Graham Denning is another. I've never used this one or heard of it, but Harrison Rosell Ullman model. I think that one actually might be mentioned in your textbook, and then the Chinese wall method. So there are other architecture models that you can look at. And the reality is, most access control systems, we kind of combine or use elements from different models to build a real world working access control model. So, a lot of times we're not using just these models in a certain architecture. We're kind of coddling together different models to get to a system that meets our needs in our organization. So now I'm going to talk more specifically about technology that we use for authentication. So there has to be some standards and protocols in place that support all this stuff, that allow authentication and so forth to work on a network. And there's a whole bunch of different examples. I'm going to talk about 5 of them here. I'm sorry, 6. I'm going to talk about 6 that I think are worth mentioning, either because they seem to be common in IT right now, or maybe they're kind of emerging. So authentication is the process of verifying the credentials. And it's not only verifying the credentials, but it's also presenting and managing those credentials throughout the life cycle of that user's authentication. So in other words, if I'm a user, I authenticate one time, hopefully. And then from that point forward, I am presenting those authentication credentials down the road, which involves this concept of trust. And I'll give you an example. Take, for example, getting a driver's license. If you wanted to acquire a driver's license, your first step is to go to your local motor vehicle center. So when you go there, they want to identify who you are. So, and nowadays, I live in New Jersey, and to identify who you are in New Jersey is a big pain in the neck now. They have these rules where you have to bring in all this documentation, and you have to bring a birth certificate and your passport and a bill from a utility company and maybe a bank statement. You have to have a certain number of points. And the whole idea is that they're trying to vet to make sure they know exactly who you are, that you're not trying to get a driver's license under someone else's name. Back in the old days, it was easy to get a driver's license. You showed up with a birth certificate, and that was it. And getting a birth certificate wasn't that hard either. So I think they realized that there was some possible trust issues there. So they made it very stringent. But once you get a driver's license, so once you have a driver's license, that proves who you are, because the DMV already went through all the work to identify you. So the DMV does all of this work to verify who you are, and we implicitly trust the DMV to do that work. We trust that they did it correctly and that they properly identified that person. And then once you have that ID in your hand, you can use that to prove your identity without having to bring along all those other documentation. So, for example, if I'm going to go on a trip to, on an airplane, I go to the airport and I can show TSA my driver's license, and they don't need to see all that other information. They don't have to, figure out who I am because they trust the driver's license. And there are certain features built in the driver's license that enhance that trust. There are certain security features that they can use to sort of vet whether you have a real driver's license. Most of you are college students, so you're probably rather familiar with the idea of a fake ID, right? Especially if you're under 21. But when you go to the airport, you can't pass off a fake ID that you bought on the internet or that you made on your printer at home and laminated. It's just not going to work. You might be able to use it to get into a bar, but that trust, vetting that identity, there's protocols and standards that are in place to do that with things like a driver's license. So we do the same thing in IT. We have authentication services that are responsible for verifying your credentials and doing the work to verify your credentials. And once they do that, then they can present those credentials to other resources on the network, and we rely on those networks. So you can think of these 5 services that I'm going to talk about as sort of the DMV of computing, of IT security, because their job is to authenticate, to identify. And then once they authenticate and identify, our other applications need not concern themselves with that authentication. They might concern themselves with authorization and understanding who can access what, but we don't have to worry about the minutia of figuring out who people are. That's already been done by some other service that's giving us those trusted credentials. So the first one we talk about, let me just advance this slide here. So the first one that we talk about, let me get through those 6, is Radius. So Radius is Remote Authentication Dial-In User Service. Now, that sounds old, right? Developed in 1992. Good Lord, 1992. Some of you probably weren't even born yet. But 1992 was a long time ago. So some people look at this and they say, gosh, dial-in, who uses dial-in anymore? That's crazy. But Radius is coming back because the standard wasn't limited to just dial-in, even though the acronym might have D for dial-in in it, but it works in other technologies, other networking technologies. So it was originally for dial-in access to, say, a corporate network. So you would dial in with a modem, and then there was this would authenticate that user to the network so that they can then access, stuff on the network. With the development of IEEE 802.1x port security for wired and wireless LANs, Radius has been gaining traction. Because 802.1x is now pretty common for port authentication. I'll explain what that is. So let's say you have a network and you have ports. You've got Ethernet jacks all over the building, right? Somebody could come in with a laptop, jack into an Ethernet port, and instantly get on your network if you have a DHCP server, and it just hands out IP addresses to anyone. They jack in and they're on the network and they can start accessing resources. So a lot of organizations saw that as a security hole, as a security concern, and a vulnerability. So there was a need for some way to authenticate devices when they plug into a port. And that's where 802.1x and Radius come in. So 802.1x is a standard that has that allows for the authentication of devices that are jacking into a port. Not only jacking into a port on the network, like an Ethernet port in a wall, but also authenticating to a wireless network. Radius is one of the services that can support that. So it's one of the common ways that we can support port authentication. So in Radius, you have this concept of a client, which is a device like a wireless access point or a dial-up service. A Radius client is not the device that's requesting authentication. It's a device that mediates those requests, like a wireless access point or a dial-up server and so forth and so on, or a switch, for example, might support this. So the Radius server authenticates and authorizes a Radius client request and sends back the Radius message response. And then once they're authenticated, they're able to use the network. So here is a picture that shows you basically the process. So first, we have a user that has a username and password that's on a laptop. They're going to try to connect to the wireless access point. The wireless access point is going to ask them for their network user ID and password. And then using Radius, it's going to send the authentication request to a Radius server. So you'll have a Radius server somewhere that the access point is connecting to. The important thing about this to notice here is that when a user is authenticating to the network with something like Radius with 802.1x, they're not actually connected to the network yet. So this is before they get an IP address. This is all happening before they get on the network. So it's not like they have to connect to the network in order to authenticate, which is traditionally how network security works. So we would have, the ability for users to connect to the network, but then they would have to authenticate to something like a domain controller to access resources on the network. But that doesn't mean they can't get an IP address and start, putting traffic on the network before they're authenticated to that server. And they may never authenticate to that server. But in this case, they have to authenticate to actually connect to the network before they can even get an IP address. So it's a lot different. So anyway, our authentication request goes from the access point to the Radius server. The Radius server is going to compare with the user database. They might look up something in the accounting database, and then they're going to acknowledge the authentication back to the access point. Once the access point realizes that the user is allowed to authenticate, that it's a valid user because the server has told them this, it gives it a token, and it goes back and approves the laptop to connect to the network. And at that point, that device can now connect to the network. If they move to a different access point, they may have to re-authenticate. And in some implementations of the standard, those authentication credentials are cached and it automatically renegotiates. For example, with Windows, when you use 802.1x with a wireless or wired connection, it caches your credentials so that it automatically negotiates every time you try to connect to a different access point or a port. So that's basically how Radius works. So again, Radius started out as an older technology, but it turns out that it works pretty well in conjunction with 802.1x, which is a newer standard. Kerberos is, according to the textbook, it was developed at MIT, and it uses encryption and authentication for security. In other words, Kerberos supports encryption for the authentication process for the username and password. So that's not passed in clear text. That's certainly one part of it, but the other part is once you do authenticate, it supports an encrypted and a trusted certificate that the user can present to get authentication. So this is, as I was talking about before, this is like our driver's license, which has trust. There are certain features about it that make it so that we can trust that driver's license. And that's basically how Kerberos works. In the book, they talk about how it was most often used in educational and government settings, which is not true. Kerberos is the standard authentication protocol used in Windows Active Directory. Microsoft Windows Active Directory services is probably the most common network authentication service in the world. Seems like almost everyone uses Active Directory. I'm sure that if you have a job somewhere, there's probably a 95% chance you're using Active Directory. So Kerberos is probably the most commonly implemented of these authentication services. I would say it's rather ubiquitous at this point. And that driver's license I was talking about that Kerberos uses is called a Kerberos ticket, which contains the information linking it to a user. So this is what's presented to network services or presented to servers and to other resources on the network to allow you to use those resources. They're very difficult to copy. They expire after a few hours or a day, so you have to re-authenticate constantly. So again, it's very secure, it's encrypted, and it's really become sort of a de facto standard in the industry as far as because of its implementation in Active Directory. TACACS is a little less common than the other services that I talked about. So TACACS is an authentication service used on Unix devices. Communicates by forwarding user authentication information to a centralized server. There's Extended TACACS, which was developed in 1990. Again, kind of an old standard, but then TACACS Plus is the current version. And again, it's used mostly in the Linux world for certain authentication services between Linux devices. So, for example, if you're using certain network file system and things like that, like NFS. It might use TACACS. Directory services, I've used the term directory services a number of times, but in reference to Microsoft's Active Directory directory services, which is, if you're familiar with a domain controller, they call that a directory service. And basically, directory service, all that means is it's a database stored on a network that contains the information about users and network devices, or all of the objects, right? So it's a database of all the objects and all of the subjects. And it keeps track of all of those resources and what the privileges are for those resources. And it can grant or deny access based on that database. So there's an old standard, X500, which is the standard for directory services, that basically Active Directory is a real-world implementation of directory services. It works well. A lot of people use it. Like I said, they probably have 90% market share. Active Directory, which is a perfect textbook example of directory services. There are other options, though, for directory services, and one of those is LDAP, or a Lightweight Directory Access Protocol. So LDAP is defined in X500. Basically, it's a simpler subset of directory of directory services, which I described before. But LDAP, unlike Active Directory, LDAP is very standards-based. It's because it's simpler to implement. It can be implemented across many different vendors. So lots of different vendors support LDAP. One of the problems with Active Directory in Windows is it only seems to work seamlessly, Active Directory, with other Windows devices. So a Windows workstation has no problem authenticating to a Windows Active Directory server, and Windows applications seem to have no problem working with Active Directory. But if you're an application developer that's not in the Microsoft ecosystem, or maybe even in a completely different ecosystem or platform like Linux or Unix, or embedded devices and so forth, it's very difficult to implement with Active Directory. LDAP is much simpler, much easier to implement, and it's also pretty secure, LDAP. So it does have some security features. It can be encrypted, just like Active Directory. But we can do this from just about any device. So some of you have probably heard the term single sign-on. That's all the rage now. Everybody talks about single sign-on, which is the concept that if I'm on a network, I should be able to sign on one time into the network. I should be able to log in once. And then those credentials, that token that I get from Kerberos, for example, I should be able to use to access anything on the network. And I should not have to use multiple accounts. I shouldn't have a different account, say, in the database server in Oracle, for example. Let's say we used Oracle. I shouldn't have to have a separate account in Oracle, because if I ever change my password in Windows, my Oracle account password stays the same. I have to go and update that one as well. And then you have multiple password management policies that you have to have in place, and it just creates a nightmare. You've got different accounts splattered all across the network. So LDAP, if we can support that on our network, it's much more widely supported than something like Active Directory authentication, and you can authenticate on pretty much any device to any service. So we're seeing LDAP being implemented in networks, and actually LDAP is natively supported in Microsoft's Active Directory. So you can enable LDAP in Active Directory so that way your Active Directory user accounts that you're using with directory services in Microsoft can also be exposed for use from LDAP applications that can't support or don't support. For example, you can integrate directly to Linux servers using LDAP for services that are offered from a Linux server, where it's much more difficult to do that with Active Directory. So again, important concept. LDAP supports something like single sign-on. Now, the thing about single sign-on that I talked about is single sign-on would only really work inside the organizational boundary because of the level of integration it requires and so forth. SAML, which is kind of an emerging authentication standard, works outside the organizational boundary. So you can use SAML with anything. It's a security assertion markup language. It basically uses XML, it relies on the XML standard, and it allows you to do secure authentication outside the organization through the web. So, for example, you could sign in to a portal maybe on a company website using your Gmail credentials, for example. And a lot of people say, gee, why would somebody want to do that? Why would somebody want to use Google as their authentication server to allow someone to access an internal resource within the company. And I'll tell you exactly why. One of the trends right now in IT, which has been growing very quickly, is companies moving to using something like Google or Microsoft, Outlook 365 or something for their email services. And even to the point where companies are now starting to use things like Google Docs and Google Drive and so forth, where every person in the organization has access to those resources through something like Google. And Google is just one example. There are other companies that do this, like Zoho and so forth. But this sort of cloud integration is becoming necessary because maybe we're not going to use our own authentication anymore. All of the authentication is already happening with Google. So if we only have certain things that we need that are internal, we could always use something like SAML to do that authentication with an external source. Now, SAML, when I created this course, and here's the steps basically. I don't want to go through all of them because I'm going over on my time limit here, but SAML is kind of an emerging standard, but there's another standard called OAuth 2.0, which is sort of already replacing SAML. So at the time I developed the course and put together this presentation, SAML was certainly a great option, but I probably should have had Open Authorization 2.0 in here as well. OpenAuth 2.0 is used by a lot of the larger web properties like Facebook and so forth and so on. So I certainly encourage you to look into OpenAuth or OAuth 2.0 as well. And there may be other standards that are emerging as well. You could probably search around the internet and find other APIs or other supported methodologies or standards and protocols for authentication. So you can certainly take a look at that. But the concept of SAML is what I mostly want you to be familiar with, is this concept that we can use standards and protocols to authenticate outside our own organization, beyond the border of our organization. And there are secure ways to do this, so you don't have to be afraid of it. A lot of IT security managers think, gee, this is something I don't have control over, so I'm not going to trust it. I'm not going to rely on it. But whether we like it or not, this is the wave of the future. Everything's starting to move towards the cloud, for better or for worse. There are good and certainly bad reasons to do that, but from a financial perspective and a business perspective and integration perspectives, this is the direction the world is moving. So we certainly have to be prepared and understand it and try to do it in as secure a way as we can. And things like SAML and OAuth 2.0 are ways that we can leverage those technologies.